Dr. Herb Schilder used to like to say, shaping facilitates cleaning and shaping facilitates obturation. There's no way we can have a conversation about disinfection unless canals have been optimally prepared, we have great access, and then we can discuss all the different aspects that go into disinfection. The EndoActivator is a contra-angled cordless handpiece that receives 3 different choices of different sized tips. There are many applications for the EndoActivator with its polymer tips. In the context of this show, we're speaking about debridement, smear layer, and biofilm, but certainly many international dentists use calcium hydroxide in the instance of 2-visit endodontics. Further, in retreatment and apexification cases, it's common to use mineral trioxide aggregate. A polymer tip can very kindly adapt and move dental materials into root defects. And finally, when we're talking about retreatment and removing gutta percha, silver points, carriers, or paste fillers, once the bulk of those materials are out, we can use a polymer tip with a solvent like xylol or chloroform to help remove residual materials. The clinical protocol for utilizing the EndoActivator is to select the properly sized and tapered tip that will fit within 2 millimeters from your full working length. The tip must be absolutely loose at the 2 millimeter level, so the tip will have the opportunity to move back and forth in a full amplitude. We'd like to activate 17% ethylene diamine tetracetic acid for 1 minute. This can then be vacuumed out with a handheld syringe, fill the tooth brim full with full-strength sodium hypochlorite, and then activate the same canal for 30 seconds additional. In preparation for clinical use, we will use the EndoActivator sterilization bag to go over the contra-angled handpiece. We can take the pre-selected tip, and if there's narrow interocclusal space, we can pre-curve the tip to help us get back in the more posterior teeth. Alternatively, you can use a sharp scissor and just trim off 2, 3, or 4 millimeters of the tip of the instrument. Alternatively, we would pre-curve the tip if we were working in a retreatment situation where we could not remove a ledge. In any event, the tip is snapped over the rocker arm, the unit is activated, and the tip is inserted into the pulp chamber. Notice all the clinical activity. It's pretty exciting to see all these bubbles emanating up towards the occlusal table during use. Notice all the debris in this pulp chamber once the EndoActivator is removed. To better appreciate the activation, though, suborifice level, we need to look at the simulated model. In an animation, you can see when the tip is free and is capable to vibrate vigorously, it begins to cause implosions, and bubbles are formed that tend to pound on debris, break it up into solution where it can be liberated during subsequent irrigation procedures. I like to irrigate and vacuum, and irrigate and vacuum, and you can do this very effectively with a 25-cent syringe. In the plastic model, we can appreciate what is actually going on inside our root canal system. When liquids fracture, bubbles are formed. Bubbles expand because of heat and pressure. When a bubble implodes, it sends out 30 to 40,000 shock waves. It is in fact these shock waves that encourage the circulation and penetration of reagent into all aspects of the root canal system, as you can see in this SEM. If we look at a higher magnification, at 1000 power, you can begin to see how much irrigant has been able to work deep into the dental tubules on the order of 300 to 400 microns. And finally, at 2000 power, you can begin to see open patent tubules, which is an ideal surface to marry our obturation materials against. Of course, other research is also emerging rapidly, and in this study by Valerie Cantor and Emily Weldon, they showed in their comparison between ultrasonics and sonic disinfection that the EndoActivator was better statistically significantly in all the areas you can see: loose debris, open tubules, and better surfaces to obturate against. If you look at different representative samples from the University of Florida work, you can see ultrasonics, you can see the control, and you can see the EndoActivator, and it's pretty clear which device provided the cleanest surface. Professor Sergio Cutler at Nova Southeastern University also has done a lot of work studying disinfection, and here is 3 representative samples he shared with me showing the EndoActivator in curved MBs and MLs of mandibular molars, and you can look at each third and see that it's very, very clean. Clinically, we can see evidence of the EndoActivator. I showed you the pulp chamber with the dirty solution, but often in the post-operative images, we're able to see lateral canals that are filled and packed to the cavo surface of the root. All these give us the opportunity to better treat root canal systems in 3 dimensions. So let's review the disinfection technique. When we're using the EndoActivator, first we must understand that there's a variety of different applications in conventional endodontics. We bag the handpiece and snap on the pre-selected tip. We're going to operate at about 10,000 cycles per minute for 1.5 minutes per canal. 1 minute was EDTA 17% and 30 seconds was sodium hypochlorite 6%. We discussed the hydrodynamic phenomenon and 30 to 40,000 shock waves for every imploding bubble. Utilizing these concepts, we can use a polymer tip that is safe and strong and flexible. Its energy is not dampened by touching dentin, and we can produce remarkably clean surfaces, as you can see in this SEM. One of the greatest frontiers in endodontic success and failure will be the study of disinfection. The best methods will emerge and will be generally implemented internationally.